Hello guys, this is CodeNCode and this is ninth lecture of Java design pattern series. In this lecture, we are going to learn one of the structural design pattern, that is decorator pattern, right? So we'll learn what is decorator pattern, how it helps you in developing uh, good quality software, and what are the components of the decorator pattern and how you implement, right? And also how you benefit from it, right? And where to use, where don't to use it. We'll learn all about it in this lecture. All right. So let's get started. So to be honest, this is one of the easiest design patterns out there. So the decorator pattern, to understand. So the definition is that decorator pattern allows you to add behavior to existing objects without modifying the original class. Right. So what happens if you want to add certain behavior, let's say logging, right? So you can, what you can do is actually you can define the logging function that logs a message in the class itself to whatever class you want to implement logging into, right? But the issue is that when you do that, all of the object of the class has that feature. There are scenarios where you only want to have certain characteristic to be added at the runtime and different combination of it. For example, you are developing a game, you have a character, it achieves certain power, you give it flying abilities, right? So the object, the game character object that you have defined, that class, uh, we have an object of that and we want to add functionalities at the runtime, right? So instead of defining a class and implementing all of the features uh, directly, that would give all of the objects of that class same behavior. We don't want that. We want certain. There are scenarios where we want to add certain behavior at runtime only to certain object, not to all of the objects. In that scenario, you'll use decorator pattern. So now. It basically adds behavior to individual objects at runtime, which is dynamically, right? Without modifying their class, of course. And also, it traps an object within another object to give it functionality, right? That implements the same interface, enabling flexible and reusable composition of features. Important part is that it does it using composition. How? I'll explain that. Right. So yeah, if you're working with Java, you have already seen that you define a scanner and then you pass the input stream, right, inside the scanner, right? So what you are doing, you are wrapping an object inside another object to give it certain functionalities. That's exactly your decorator pattern is, right? So let's go ahead and see certain scenarios. As I was already explaining this, so we have a game, we are building a game and we have a character, basic character. It doesn't have any powers and all. So let's say you wanted to add certain powers it attains after doing some work, certain tasks, right? And then you wanted to give it flying ability. So in the GUI, you can add a cape to the character that will show the user that, yeah, now it has the flying abilities. And in the object of it, in the coding side of it, the object of that character, you can add flying abilities in that object. Now, we have stealth abilities. If you want to give it stealth abilities, what you can do, you can add a mask onto these my bad, onto this character's face, and now we know that it has the stealth characteristic. Now, again, in the object, you can add an extra. You're required to add an extra feature at the runtime again. And let's say for to make it fast, you can add a new boots, upgraded boots, and now we know that the character has fast speed. And again, in the object, you are required to add a new feature, right? Basically, you have a superhero. Not just this, these feature, you might want to add different combination of it. Flying stealth only, flying fast only, maybe stealth fast, right? Things like that, or all of the combination. So they're not just different features we are required to add at the runtime. We also are required to add different combination of them, right? And doing it using a single class inheritance is not a good idea. Why? Let's look at that also. So if you want to do it with inheritance, like you have defined an object, you have defined a class which is a character class, and then you are implementing different features directly then and there. Right. So if you do that, what issue is it brings it is the class explosion problem. So using the inheritance, you want to add multiple supports to it, but that grows exponentially. For example, let's take a different example. We have a base class window. You want to create a different windows of it, right? and features are scrollable and bordered. So different combination would be scrollable window, bordered window, scrollable, bordered window. So three different class we already have. Let's say now you want to add an extra feature. How many combination it would bring? Now, let's say I wanted to add lockable window, right? So now I'll have lockable scrollable window, bordered window, scrollable bordered window. So you see, just by adding a new feature, I have to create three different classes. And if I keep on adding new classes, new features, it would just keep on exploding. To be honest, it is 2 raised power n, where n are the number of features. Okay. To be precise, 2 raised power n minus 1. Right, that many, and 2 s power n is exponential, so you will have exponential different classes. That's not a good design, of course, right? And this is just one of the examples, the class explosion. While adding a new feature, I forgot to add this text. And now the other issue with inheritance is that you can't add features at the runtime. That is not supported. So that's another issue. And the third one is that you are not able to add features to individual objects, right? When you define a class, all objects of the class have that feature. So we don't have option to add features on individual objects. We don't have feature to add feature at the runtime. So these are some of the issues with inheritance. Right. So let's see how decorative pattern solve this issue. So the way before I explain the components of decorative pattern, the way decorative pattern solve these issues, instead of using inheritance, it uses composition. And you can define different abstract classes of it. And my bad, you can define different classes of decorators, right? And each decorator will have a specific feature. When you want an object to have that feature, just wrap that original object into one of the decorators, and the wrapped object now will have that feature also. So you will understand it better with an example. I'll explain that also, but let's have a look at the components of the decorator pattern. So first of all, you will have the component. So it's an abstract class or interface of the component which is to be decorated. In our case, it would be the character. Character needs to have different features at runtime, so that would be your component. Could be in one interface on abstract class up to you. Now, in our case, it's logger. So a concrete component. So basically, implementation of that. So you can have console logger or file logger, right? So basically, implementation of that. When you have a character, and then you can have multiple character. If you are talking about games, Superman, Batman will be the concrete implementation of that component, right? So now this is basic stuff, right? Now the decorator part starts from here. Now you can define an abstract class decorator, and now using this you can define multiple kind of decorators, right? So you can define decorator, which is an abstract class, so basically what it do, it will either extend or implement the component, because it needs to add a feature to a certain component. So what it will do, if you will define a decorator, let's say logger decorator, right? And then inside of it, it would either implement or extend it, depending on whether your component was interface or abstract class, right? And also it will have a reference of the component. So what we are using here is the composition, right? And now we simply inside this decorator will delegate the call. But before delegating the call means doing certain stuff like walk for a character, walking, flying, sorry, just walking, attacking, things like that. Those are original features. Now you can add the feature before and after performing that operation. For example, if I was building certain service, and after, let's say, transaction service, I made a transaction, ATM withdrawal. Just after the ATM withdrawal, I wanted to log a message that successfully amount withdrawn, right? Withdrawn. So I wanted to add a feature of logging. So in the original object, I'll add a logging decorator, and just after performing the operation, you see, delegate call. The call that we are talking about is the actual operation that you want to perform, and before and after you want to add certain features. So the feature that you would add, not just that, and you can add extra features before without delegating the calls also. So in our case, just after completing the call, I'll add a log, right? So I'll come first of all delegate the call to the original object, and then add the behavior, which is logging. Just after completing the transaction, I'll add a log message. And now this is the abstract class. You can define the multiple decorators. using the abstract class of decorator. So this is basically logger decorator. Using the logger decorator, you can define multiple kind of decorators, right? This is basically the base class. This is concrete classes. So we have concrete component, basic stuff. This is where decorator starts. That you define an abstract class, and then inside of it, you will have a reference to the original component. This is composition, right? And since we are using the composition, it won't matter how many different type of this concrete component you define. Even if you add a new component, you don't have to change anything in the decorator. How? I'll explain that using the code. All right, so let's jump into the code editor and let's see how we implement it. All right, so let's say I was building a compiler, right? So I have a compiler here. So I've defined an interface. So this will be a component, right? So I've defined an interface. I've defined a component using an interface. You can do that using abstract class also. It's up to you. So that I can define multiple types of it, right? So I have a compiler which only has a single function called compile. I've defined one of its implementation, basically the concrete component. So it implements compiler and overrides the function, right? Compiler is Java and compiling code, this and that, right? So this is a compiler. If you want to add a new compiler, CPP compiler, Python compiler, XYZ compiler, you can do that here, right? So we have component and concrete implementation of that, right? So if you see here, component, concrete implementation. Now inside this component, you want to add extra feature. For that, you can define the decorators. In our case, let's say I want to define a feature so that once I have completed the execution of a certain code, I print something, log something that yeah, successfully compiled. Or just before I execute the compilation, I want to log a message that going to compile this code XYZ, whatever that is, right? So I want to add logging capabilities here in the Java compiler, right? In the compilers, to be honest, it could be any kind of compiler. So what I can do, I can define decorators here. You don't have to name them decorator. It's completely fine. You can name them anything you want. I have named that logger, right? So now logger, as you can see, is an abstract class. So if you look at here, this is decorator, right? I've defined it using abstract class so that I can define multiple kind of decorator, multiple kind of logger decorators, right? So I've defined logger, and it has a compiler in it. This is composition, right? It has compiler, not Java compiler, not concrete implementation, but the actual component, right? So I have compiler inside of it, and I'm just setting the compiler, and it also implements or extend depending on whether your compiler is interface or abstract class, right? So you either extend or implement the compiler, right? Or your component. We are doing it for a reason. I'll explain that also. So now that I have a abstract class, right? We have a decorator. I can go ahead and define different kind of decorator. I want to create a logger which logs after doing a certain task, which logs before doing a certain task, and which logs before and after doing a certain task. So let's talk about before logger. So what it will do, first of all, it will extend the logger, right? So this is concrete abstraction. Sorry, concrete decorator. So of course, if it is going to extend the logger, and you just define the uh, constructor and pass the compiler to the super base class where we are going to set it, right? Now that I have before logger, first of all, this is basic stuff. You are defining the constructor only and calling the super, right? Now we need to override a certain method. Since we are extending logger, my bad. Since we are extending logger and logger extends compiler, will define the function inside the compiler, which is compile, right? We are doing that, and since this is a before logger, I want to add a feature to log before doing the operation, before delegating the call. So just before I delegate the call, I'll delegate the call using the compiler. We have the compiler because inside the logger we have defined the compiler, right? We have the compiler with us, and as you can see, the compiler is defined using protected so that the inherited class have the compiler also. Now I have it, so I can call the compile code, right? So before delegating class, I want to do something. What I want to do, I want to print something, log something, right? This is a before logger, so I'll log before performing the actual operation. So you see what we are doing, we have an abstract class, the decorator, and inside of it you will have the reference to the component, right? So we are using composition. Now I have defined logger, right? Inside of it, I'll simply override the method, and then you can add feature. Here I have added the feature of logging before or after the delegation of method, right? And similarly in after, I'll first of all delegate the call, and then I'll log it. Similarly in around logger, I'll first of all log it before, then I'll delegate the call, and I'll log it after. Right. So three kind of decorators I have defined. So if I go ahead and define a compiler here, compiler, compiler is equals to new Java compiler. I have a Java compiler. If I do compiler dot compile hello world, if I do that, you see, uh, what compiler was used and compiling code this. Okay, simple. Now I want to log certain messages, the feature that I have added before going for compilation. So what I can do, compiler is equals to new uh, before logger, before logger, and I can pass compiler here. You see what happened. I can set before compiler to compiler because the decorator that you have defined either implements or extends the compiler, right? So you will be able to set it after. That's why when you are defining the decorator, it will either implement or extend based on whether your component is interface or abstract class. Right. Once you have that, you can set it back to compiler. So you have wrapped your compiler inside before logger. So once now you have capability of logging before doing the compilation. So if you run it again, you'll see before the compilation, we have the logger. We have the log message here because we have added the functionality of logging before the compilation. I can do one more thing, and you can actually chain this thing. You can actually combine these features, right? As we talked about it, that we can not just only add new features to existing object, we can also combine them. So if I want to combine the before and after both, new after logger. So I have added feature before logger and I have added feature after logger. That means before we will get a log message before and after execution of this code. So if I go ahead and do this, if you see, we have a log message before compilation of the code, then message is being compiled, sorry, code is being compiled, and then after also we have log message, right? So we can not just add feature, we can combine them. And instead of uh, adding two different features, I've already defined around logger. That means it will log message before and after compilation. So I only need to add one feature and it will log before and after compilation. So if you see, as you can see, around logger is logging, about to compile the code, around logger is logging that code compilation is complete. See, so you can add new features to existing objects using the decorator. How you define it? You define a decorator you can using abstract class so that you can define different types of it. You implement or extend the original component because you will set it back to the same reference, right? That's why you will either implement or extend it, and then you'll also have a reference of it because it uses composition. Now, since it uses composition, if you add a new type of compiler, let's say CPP compiler. Let me just show you that also. CPP compiler, it will also implement compiler, alt enter, implement method. Yeah, inside of it, let me just go ahead and put it, control C, CPP compiler, control V. My bad. What has happened just now? Control C, control V. Now compiler is CPP and compiling the code. Now we have a new compiler. You see, I have added a new compiler class, right? And I had made zero changes to the logger, zero changes to the decorator. It would still work. Instead of defining Java compiler, I'll define CPP compiler. See, nothing changed, just I've changed the type of the compiler. If I compile the code now, you see, Decorator still works. We have CPP compiler and we are compiling the code. And as you can see, it's working perfectly fine. So you see, now that you are adding a new type, class explosion is not happening because we are using composition, not inheritance, right? Had I used inheritance, I had to define multiple types of loggers, right? Decorators. So yeah, this is how you implement a decorator pattern, right? So yeah, this is it for this lecture. If you have any query, question, request, anything, you can post it down in the comment section. So this is for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.